Hello, everybody. I'm Jeffrey Fox, and this is the Big Data Applications and Analytics course. And this overall motivation covers the key things going on today. Used to be focused on big data in the cloud. Now machine learning or artificial intelligence is becoming far more important. This big data in the cloud is still equally important, but machine learning has risen in importance. Previously, we used to focus on the future economy. Well, now big data and the cloud have had their impact even on the current economy and the current way of doing business and the way of doing life. So I'm in the School of Informatics, Computing and Engineering. I'm in the Department of Intelligent Systems Engineering, and I run the Digital Science Center. And this is the first of a reasonably long motivation presentation. And so let's get going. All right, this is the introduction to this presentation. And for lesson one, we have an overall set of general remarks about these topics: clouds, big data, machine learning, and the status of the digital transformation, which basically means that people are changing their mode of doing things from the pre-digital to digital, internet, cloud-enabled, big data-enabled approach. We have significant discussion of the hype curves, and the slides in this deck are arranged first with those up through the 2014, and then there is an update 2016 and 2017. And so this is Jeffrey Fox continuing. Let's get on to the first discussion of the hype curves and the general remarks. Thank you. It's going. So this is, if you like, the summary of this full unit, which has some 140 slides. And so we have all this data being gathered, and those data involve people and machines, machines talking to machines, people talking to machines, and vice versa, smartphones, smart homes, intelligent vehicles. We have science with satellites and accelerators, and particles and photons are interacting with each other. That's what, if you like, accelerators do. They look at not people interacting with machines or what have you. They look at particles interacting with particles. We store this whole stuff in immense clouds. We hope to co-locate storage and computing, but that's not so easy. The computing on the data does analytics, which converts data to information, to knowledge, to wisdom. And then finally, after wisdom, we get either decisions or community consensus or not, or insight. And then we have data mining, which emphasizes the fact that sometimes we just look totally in an unstructured fashion to see what the proverbial knowledge diamonds there are in the data rough, which is data mining. And so this is disruptive. And this disruptive transformation is driving economy and vice versa. And it's creating millions of jobs in the area of data science, which is the topic of this course. And we look at the revolution, its implications for research, education, etc. So here's some trends. Well, big data is the data deluge. Data is pouring down. We have whatever it is, 1.8 billion photos uploaded every day into the cloud from Facebook and whatever it is, Snapchat or whatever it is. And we have search, we have Amazon, we have Netflix, we have scientific applications like the Large Hadron Collider with 15 petabytes a year and so on. So that's the data deluge. We have things getting smaller, which is chips. And the reason why we can process more data is the chips are getting smaller, and therefore in a given volume or for a given amount of money, we can put more chips and therefore process more. And then originally with chips, they got faster and smaller. Now they just get smaller. So actually faster and smaller with 3 degrees of improvement, because you have X and Y of the physical construction of the chip, and T for the clock speed. Now the clock speed of the chips is more or less constant, but the feature size is continuing to decrease. So that gives you Moore's law, the continuing amount of computing. Because everything is getting smaller, we have to take a chip, which is whatever it is, a centimeter or so the type dimensions, and we can put more cores in there because the cores are getting smaller. So we don't really want chips which are millimeter by millimeter. So we are making cores smaller. We're making lots of cores in a given chip, and this is also driving, because we can get the same amount of computing in a smaller space, is driving these so-called lightweight clients such as phones and tablets and sensors. And then in the back end is where we all these tiny things lying around on the front end, because that's what the multi-core revolution is telling you. We don't really need lots of parallel computing on clients. We can do some, but not enormous. So we tend to make clients smaller. But servers in the back end are fine, because they can process lots and lots and lots of clients. And so servers use multi-core to process lots of clients. So in the trivialist model, with your nifty new 18-core Haswell chip, you can process 18 simultaneous things going on from clients on the internet. And all of this is helping you lot, because there are new jobs with new curriculum, which is meaning universities, which never like to change, might have to change. They probably won't, actually. And we need to look at clouds, or which is part of distributed systems, and therefore changes that course. And we have this somewhat new area called data science. All right, here we have the famous Gartner. We have 2012, 13, and 14. And let's look at some key things. Here's big data. And it's in 2012, it was still in the technology trigger. We have cloud computing is a little older. Here's private cloud computing, which actually is going to disappear for some reason. Maybe because it's actually now private cloud computing. So you run a cloud inside your organization. Now, actually, universities are actually just getting into doing that. But I think enterprises have realized that that's not a terribly good idea. They might as well do real cloud computing, where they share resources and get economy of scale. What are those clouds running? Well, they're running analytics. We have various forms of analytics here: in-memory, text, predictive. Actually, data analytics is revolutionizing speech recognition. I didn't highlight that with a red arrow. Speech recognition is being revolutionized by deep learning. All right, and here we have tablets, which are, of course, enabled by multi-core. So here we have all these things popping around. There's other things like importance, nifty 3D printing. There's another analytics, social analytics, and so on. Okay, so that's 2012. And in 2012, they had the largest number of technology. You can see it's pretty crowded, 48. 2008 was the lowest at 27. And they said 2012 was some sort of tipping point, that the scenarios they'd been chatting around and predicting finally started to take hold. And that's one of the key problems, actually, making predictions. You sort of know actually probably the general direction. Like, we're bound to have smart homes, but you're not quite certain when the price and ease of use of technologies is such that they're going to happen. Because people are not going to put sensors in their homes if they're hard to use, expensive, and don't really produce huge value. So that time is the critical problem. It's hard to predict. Now we have 2013, somewhat fewer technologies, a little cleaner. Here we have big data. It's inching up just below the top here. 3D printing still up here near the top. Now we have these things here, predictive analytics around here, in-memory analytics. Cloud computing is nearing the bottom. It's some things disappear into the trough of disillusionment, but the things we're discussing are going to whip through here and up into here. After being overhyped and sort of then attacked, then people actually realize they're very valuable, and they rise through this slope of enlightenment and plateau of productivity. And we have in-memory database systems, very important. Cloud software technology, Memcached is a good example of that. And then you want to put things in memory just to save time. Rushing off to disk to look something up is time consuming. Now we have 2014. This came out this August 2014. I should point out these Gartner charts are not so trivial to get because Gartner charges an arm and a leg to get their reports, and so I wait till they're published. Excerpts are published in blogs and things like that. So where are we? Well, we actually exciting. Data science has appeared, and it's coming up here. It's in the innovation trigger, so that's good. We're on the leading edge. Internet of Things is up here. Prescriptive analytics is here. Speech recognition we saw last time. 3D scanners, 3D printing really taking off. In-memory analytics and other analytics. Cloud computing is still progressing through this trough. We have in-memory database management systems in roughly the same place as before. And here's big data. It's fallen off the top. It's come through the top where it was last time and going on down. But there's nothing, I mean, according to Gartner, everything takes this cycle, whether it's super or useless. And therefore, the fact it's going down is not negative. It just got to go down to go up. That's the nature of this universal cycle. And big data is 5 to 10 years, the dark blue. Cloud computing is light blue, 2 to 5 years. Well, we didn't get much detail on what's happening in 2014, but in 2013, they went through some analysis of the types of revolution you'll see. And then you'll have machines understanding humans, so that's machines analyzing what's happening to humans and the world. We have humans understanding machines, and machines and humans together becoming smarter. And we have examples of those approaches. In particular, for machines and humans becoming faster and smarter, we have quantum computing, this so-called prescriptive analytics, neurobusiness, big data, that's what we're doing here. Complex event processing, a rather technical term. Everything in life is event processing. That's what the Internet of Things or just the way just-in-time work goes. In-memory databases, we already discussed cloud computing, predictive analytics, and in-memory analytics. These are either telling you what to do or giving you advice as to what to do. And these are the areas that are driving humans and machines getting far smarter. And that's what's covered in this course. So maybe you'll be smarter at the end of this course. Or maybe you decide you don't want to get smarter, and therefore you can give this course a miss. Fine. IBM Watson, of course, is a famous computer that competed in Jeopardy and used very interesting technologies to be able to answer those questions. Here's a nice thing, which again I haven't got in 2014 because it was not put on a blog, which is the so-called priority matrix. And then we have cloud computing. So this is transformational. High, moderate, low is the type of benefit. And here's the years to mainstream. So cloud computing and enterprise 3D printing are transformational and 2 to 5 years. And in-memory database management system is essentially a subset of cloud computing. 5 to 10 years, we have more bioprinting, big data, content analytics, more 3D printing. This mysterious complex events processing, I don't quite see that as in the same league as the above. Machine to machine is certainly important. I don't see why it's so difficult for them to communicate. Robots are enabled by clouds because clouds control robots. Autonomous vehicles are the most obvious, drones, self-driving cars, and so on. And here we have Watson answering questions. Internet of Things is certainly happening now, and some things are very pervasively available, webcams, smartphones, etc. Quantum computing truly is far out. I find it interesting the brain-computer interface has moderate benefit. It's almost worth, and also the speech recognition has moderate benefits. Sort of interesting. What's not so promising. Still, we're not studying those in great detail, so it's okay, whether or not it's right or not. All right, let's go for it. Here's a nifty plot on the scale of things that comes from this KBCB. Mika is the name of the lady who gives this talk, brilliant talk every year. And this points out how every computing cycle, the installed base is 10 times greater than the previous cycle. And you start off with mainframes here. And here we have mobile internet. And later on, we'll have the Internet of Things. And we have desktop internet. Remember, desktop and PCs are declining. And we went through. I started with mainframes. Well, I started actually with crummy computer. When today's, the very first computers in 1964, they weren't really mainframes. They were. I remember I used to have cards where we had to punch every hole in the card to actually tell the computer what to do, and it whipped around with its 4 kilobytes of main memory and actually did useful things. That's what inspired me to take up computing. And here we have the final slide, issues of importance. This will be explored further on in this talk, this motivation talk. We have the economic imperative. There's lots of data and lots of jobs. The computing model that industry adopted clouds, and so we really must know what a cloud is. Research model, that all this data is changing the way science is done, the so-called fourth paradigm of data-driven science. So we have lots of nifty new computing opportunities and new computing technologies and new computing algorithms. We have all the opportunities because whole new fields are being opened up. X informatics for lots and lots of values of X invoked by applying fourth paradigm. I don't know, to running a bus fleet, or as well as finding new Higgs particles. And then here, on a more modest fashion, humdrum, I should say, we have the fact that sort of internal to this talk, relevance for this talk, just operationally, the data science is an issue of importance raised by these revolutions. So that's the end of lesson 1 of unit 2, motivation. So this is the introduction to the motivation. And the motivation is the motivation of the course, and sort of related to the introduction of the course. Thank you very much. Jeffrey Fox signing out. Okay, now we come to 2016, skipping 2015. And really there's a sort of striking change. Some of the core driving technologies, clouds and big data, have been just dropped from the high technology graph because they're just, not because they're unimportant, because they're so well established. They're now focusing on more details of those trends, although they do put cloud, mobile, social here under the, this is going through the trough, and actually they're all roaring up this slope, although they're not spelled out in detail because, as they say, you need to take what you know about clouds and mobile computing and just implement it better and make certain you can run larger jobs and things like that. The 3 trends which are changing dramatically is, first, the huge emphasis on artificial intelligence, all these AI-first companies like Microsoft, Facebook, Google. AI has shown itself to be incredibly successful with these examples such as language translation, voice to text, and smart assistants like Alexa and Siri and the Google Assistant. And then this is driving a digital business, which also has its own new technologies. The Internet of Things is really advancing very fast. Blockchain's an important database technology. Wearables are a subset of the Internet of Things. The digital workplace and 3D printing. So that's sort of coming across here and is now moving down, which means that it's getting established. It's sort of funny that everything moves down even when they're going very well, and actually they also move down if they're doing very badly. But these are all doing very well. And these are driving new approaches and have new startups and new dramatic things happening. So if you look about the differences from 2015 to 2016, there's a change of 2 in the number of technologies. In fact, 2 more. 14 were actually removed, including the sort of last interesting cloud computing general category, hybrid cloud computing, the mix of public and private. General purpose 3D printing is now well established in both consumer and the enterprise areas. And there's a funny thing here called advanced analytics with self-service delivery. I think they just, that was just another very clever idea. Although both are good, analytics and personalization are both excellent. Notice I've colored things according to 3 categories, which are the categories covered in this course: computing systems, big data related things, and the Internet of Things. The new technologies include blockchain, this database technology, machine intelligence, neuromorphic hardware, that's all brain-related computing, because the success of deep learning has emphasized the neural net types approaches, which are brain analogies, are pretty successful. Various, this is again a reasonably sophisticated, I doubt that this one will survive, data broker, platform as a service. Personal analytics, that's very important. Everything should be personalized, personalized medicine. And personalized medicine involves running data analytics focused on you. Smart workplaces, that's obviously important as a smart data discovery, which means use more AI and things like that. UAVs have dramatically increased in use, with drones having particular attention, but also autonomous cars receiving daily attention on the web. Connected home are finally starting to take off a little. It's still not dramatic, but Alexa again illustrates that, as do smart thermostats, smart lights, smart switches, and so on. Machine learning is actually pretty interesting. It's a very general topic, and it's actually sitting there on the way up. I think it will come up so fast it will hit the top and go down again, because it's really advancing. It really already is very mature. Software-defined anything just means that everything is defined by a script, and you execute the script to enable it. And that includes everything from computer software itself, computer systems, and so on. And here we have some metadata thing trying to document whatever we have. And that's sort of related to software-defined anything, because unless you can define precisely what you're talking about, you can't really. Unless you know what a computer is and how to specify the amount of memory and how to specify how things are organized, you can't actually use software-defined systems. All right, so we come now back to the mega trends, which you actually showed on the first of these sets of slides. The core technologies, which they call Nexus technologies, have moved on. That's rushed through the trough, and they're moving up rapidly into the platform of boring acceptance. And that's where cloud and big data and mobile and social computing are. These are what they call the forces in the previous analyses. So everybody knows they're important, even though I personally don't find some of the social networking features as useful as other people do. And then we have these digital business technology using these basic ideas, including cloud computing, to drive electronic business approaches. Well, probably the most obvious, again, is self-driving cars or self-driving vehicles, automated warehouses, and just Amazon selling you everything under the sun in an automated fashion without any bricks and mortar. Design and innovation with new approaches, and that says that all of this is actually giving a focus on people with good new ideas. So there are lots of startups. When I went to Consumer Electronics Show, January 2017, the number of startups was amazing, and lots of them were trying to harness machine learning and cloud with back-end clouds to try to add value to everything you did, from looking after your pet to managing everything you have. And then we have one aspect of what I just mentioned was artificial intelligence. We've always had artificial intelligence and we've always had machine learning, and actually pretty advanced. What's happened is everybody now understands how important they are. And like Tesla replaced the head of its self-driving car effort by a machine learning expert. So the importance of these core analytic technologies has now been emphasized and has even greater emphasis in the business practice. And this has produced, these trends have produced shifts, which shifts are effectively implied by our previous remarks. One shift is the emergence of the Internet of Things, of which wearable technologies are a subset. Actually, it's sort of interesting. Wearable technologies are not thriving because Fitbit is losing market share, Apple is gaining market share, and the dedicated technologies are being replaced by these smart watches, which have everything put on them and are not so specialized. We have these multidimensional printing becoming mature, which of course, so you have 4D, time-dependent printing, 3D, and you can print everything from drugs to drones and wearables. And also you can print the implants that allow you to cure your disease when you have to have an organ plant. Sports obviously are pretty impacted by this. All right, now we come to another shift, which is again implied. We're in the age of artificial intelligence, and we're in the age of AI-first companies. And deep learning is a particular technology there. It does not do everything. Basically only really is a way of capturing. If you have a lot of knowledge, it will capture that knowledge and allow you to use that existing knowledge in an area to make predictions and classifications about similar things to what you learned knowledge about. So it'll allow you to take images and classify those images if they're hippopotamuses or cars or what have you. Actually, you can do more precise classifications than that because they've already been told what a hippopotamus in a car looks like. And these are the things connected to the personal world, which machine learning and deep learning is helping. And you have smart parking. Smart cities are a huge effort. There are many initiatives in that area that include smart transportation. Obviously, lots of people would like to take IoT-enabled cars. Of course, the connected cars are a growing fraction of the vehicles, or connected vehicles are a growing fraction of vehicles. And those enable, of course, smart decisions to be made because you know where vehicles are, where there are jams, and so on. Retail are making more and more interesting discoveries, which they use to exploit and offer you things to buy that you didn't realize you wanted. Healthcare is very important. We have at Indiana University a precision health initiative, which is sort of designed to exploit this shift. And here are just some examples, which include things I understand, like vehicles, but I'm not quite certain what smart contact lenses are in detail, but they sound a good idea. All right, the next two shifts are associated with security and clouds. These have been very important forever, and now they're just mature. and they are not totally mature. Like recently, there's a whole new interest in so-called serverless computing, and on the 2017 hype curve, serverless computing enters into the on the rising part of the curve. So that's a refinement of the basic concept of infrastructure as a service and platform as a service and software as a service for clouds. Security has now added a more detailed version of that, blockchains, which have gained a lot of attention as a way of doing distributed management of ledgers. Crowdsourcing has always been important, but now that's getting more robust. And so here we have a maturing, but still rapidly changing in critical areas, security and clouds. And these have to scale up and out. So they have to do more and do whatever they are doing now faster. So they have to use more computers to run things in parallel faster. And they have to do many more things, because many more things are enabled by these technology advances. The smartness is much more pervasive. So we have these themes: intelligence, that's again artificial intelligence. Digital, everything is done digitally, not in the real world. So here we have machine learning, intelligence. Those are parts of intelligence applications, and those enable intelligent machines and robots and cars and what have you. In the we have digital twins, which are simulations that enable you to study things on the computer which you want to explore. Virtual and augmented reality are building virtual worlds and using those to use because your eye is so powerful, using your eye to make more important advances. And here we have blockchains, which are distributed ledgers. Then we have the mesh, which is sort of putting everything together. That's a nice term. I don't know anybody else, but Gartner thinks of that term, and that involves all of these: the security, the digital technology platform, the systems which relate that to people. So this is people, software, and computer hardware all integrated, interacting together. All right, so we finished this section with the two hype curves. Here's the hype curves for 2016. And again, it is most notable for not having clouds on it. It has quantum computing. It's had that for a while. Quantum computing is actually sort of interesting. It's more hyped because it's still far from near a solution. General purpose machine intelligence, I would rate that as further advanced, the same as smart dust, which is just having tiny entities which can enable you to build very small Internet of Things. Machine learning is here right at the top. I would again put it further on, because effectively machine learning has been around and has been used for a long time. What's happened is they've got more attention now because of its success. Autonomous vehicles are, every day you see a new car federation or a new advanced. Tesla introduces the Tesla 3, BMW and Fiat Chrysler start working together, and so on. Here's software-defined anything, which is basically this concept that nothing is, everything is defined, if you like, by a file or a data set, which just specifies what you have to do to build that thing, whether that's being built by 3D printing or deployment in DevOps technology. That file or that data set defines how to do it. So obviously, this is a deep learning enabled thing, natural language, question answering, and these ontologies are almost finished. So I pointed out you can't have software define anything without being able to talk precisely about the things you're trying to define. So they're interesting. AR, augmented reality, and VR, virtual reality, are perceived as being mature or maturing. I think that's a little optimistic. Anyway, even in 2017, I think that's a bit optimistic. All right, so that's 2016. And here it has one of these nice charts here, which have this benefit versus time. Here's time from less than 2 to above 10. Here is totally spectacular and then transformational. And here is just high. It's interesting, quantum computing is only high. I wouldn't agree with that. If you can do quantum computing, that will so change the power of computers that it will be certainly transformational. Whether it actually happens, I don't know. So here they're actually putting self-driving cars more than 10 years. Most people would view that as pessimistic. People seem to like, so many companies are adopting electric and self-driving cars. Here we have blockchain, IoT, software, distributed small data centers, personalized machine learning, all these smart things. Here's software-defined security as an example of software-defined anything. And here's software-defined anything, which is meant to be 2 to 5 years. And it's probably so boring that it's sort of only high. It is really not a spectacular idea. It's very important and actually non-trivial because it's pretty difficult to define these things precisely. Here we have connected home, 5 to 10 years high. Maybe that's because people really haven't really adopted. Now, I would again put drones as transformational. If you can really get drones to work, that would be a transformational effect. Smart robots are again transformational, obviously, but they're not here. They're just high. Here we have 2017. Here we have AR and VR in roughly the spot they used to be, as is enterprise ontology. And if you look up here, we have blockchain, we've mentioned already, machine learning, and deep learning has sort of come up to match machine learning. Connected home, we just discussed. If you look at all these technologies, they have a pretty strong artificial intelligence flavor, neuromorphic hardware, deep reinforcement learning, artificial general intelligence. I mentioned the serverless PaaS. That's the one core cloud technology you have. The rest are all the rest require clouds to be wonderful, but they're not in themselves cloud technologies. Edge computing is very important. Edge computing is just the software model that has IoT devices and cloud devices. The IoT and associated computing is the edge. They link to the cloud, and together they address the problems you need to solve, like driving your car in a straight line, or choosing the restaurant when you want to do that from the car. Okay, here we have the 2017 hype curve topics put in just as bullets rather than on a picture. And this allows you to probably study them a little more detail. The font size is bigger. And they are also divided into 3 areas of relevance for this course: Internet of Things, Big Data, and Computing Systems. Here is the smart dust is basically totally pervasive Internet of Things. We have robots and IoT software platforms. I think those are pretty straightforward these days. They're basically implemented with clouds in the middle and related functions of service computing at the edge. We have the connected home, which of course has a lot of hardware and edge devices. There's a lot of device manufacturer, which actually includes a lot of AI, but it also is enabled by the cloud. Autonomous vehicles are the same, a lot of sensors to see what the vehicle is doing, controlled both locally on the car. If you're going to want to make a decision in 10 milliseconds to avoid a catastrophe, you will do that on the car. If you have minutes to spare, if you want to discover a good restaurant, you will just go off to the cloud. Here we have these drones, which you already commented on. And again, coming back to the computing systems, we have enterprise ontologies, cognitive computing a la Watson, and blockchain. So let's now bring this to a stop and move on to lesson 2. And this is Jeffrey Fox, the person recording all these lectures, signing off and wishing you the best. Thank you.